Good morning, students. In this section, we will discuss about distortionless transmission lines. Simply, first thing we have to identify the condition for distortionless transmission line. A transmission line is said to be distortionless if the attenuation constant alpha is frequency independent and the phase constant beta is frequency dependent. That is the first condition, and at the same time it should satisfy R by L is equal to G by C. It is the condition for distortionless transmission line. That is simply R by L is equal to G by C. That is the condition for distortionless transmission line. And here for this one, we have to find the remaining parameters, characteristic impedance and all those parameters. Now simply we know that the characteristic impedance Z0 equal to square root of R plus J omega L by G plus J omega C. It is the generalized formula for characteristic impedance. Now I am taking R as a common term from the numerator and G as a common term from the denominator. Then that equal to square root of, by taking R here, R1, R into 1, R plus J omega L by R. There is no R component at this term, so L by R, by G as a common term, 1 plus J omega C by G, 1 plus J omega C by G, that is equal to square root of, and here R into 1 plus J omega L by R into G by G into 1 plus J omega. Here we're having C by G, C divided by G, C divided by G. Look at here, it is the condition for distortionless. R by L equal to G by C. Here we need C by G, that is C divided by G, C divided by G. Then we can written as L by R. C by G means that equal to L by R. So L by R. Instead of this C by G, L by R. This time will be get cancelled. Then that equal to square root of R by G. It is the expression for characteristic impedance in case of distortionless transmission line. And now we have to go for characteristic impedance. We have to go for propagation constant. Propagation constant gamma equal to square root of R plus J omega L into G plus J omega C. Now in the same process, I am letting R as a common term, that is R as a common term, R into 1 plus J omega L by R, and G as a common term, G into 1 plus J omega C by G, J omega C by G. Now here that implies square root of R into 1 plus J omega L by R into G into 1 plus, look at here again, here we are having C by G, C by G, and again here C by G. and I am writing here L by R. J omega L by R. That implies square root of R into G, RG into 1 plus J omega L bar into 1 plus J omega L bar. 1 plus J omega L by R whole square. 1 plus J omega L by R whole square. That is equal to root RG into 1 plus J omega L by R. Here square root cancel for this term. For this term only square and root cancel. Then now I am multiplying this root RG internally. So root RG into 1 root RG plus root RG into this term. First term is root RG into this one, root RG plus root RG into J omega L by R. J omega L by R. Root RG into J omega L by R. Then that equal to square root of RG plus. Here again, look at here. Here it is root R and here is R. Root R in the numerator, R in the denominator. So root R will be get cancelled. One root R will be present here. So raise square root of G by R into J omega L. G by R into J omega L. And once again look at here. I am substituting this G by R. Our condition is R by L is equal to G by C. It is our condition. Here it is G by R. G by R. G divided by R. It will become C by L. G by R becomes C by L. So when we replace that, it will become gamma equal to square root of RG plus square root of G by R is nothing but C by L into J omega L. Now that is equal to root RG plus square root of C by L into J omega. This L can be written as root L into root L. Here root L, get cancelled. Then that equal to root RG plus root L into root C. Root LC J omega. It is the expression for gamma. And now we know that here this gamma can be written as alpha plus j beta. Now I am substituting this alpha plus j beta here. So alpha plus j beta equal to root RG plus root LC into j omega. Now compare real parts. Here at this side real part is alpha. At this side real part is root RG. Then alpha equal to root RG. And now compare imaginary parts. At this side imaginary part is j beta. This side this one. Here the j term, at j term present term is imaginary. So j beta equal to j omega root LC. Beta equal to omega root LC. It is phase constant in case of distortionless transmission line. And finally phase velocity V suffix p equal to omega by beta. Here omega is omega, beta is nothing but this term. This is beta here in case of distortionless. So omega by root LC. These two will get cancelled. V suffix p equal to 1 by root LC. It is the phase velocity for distortionless transmission line. These are the components for distortionless transmission line. Here when we observe here, the attenuation constant alpha is frequency independent because there is no frequency term present in the alpha, but beta is frequency dependent because beta is equal to omega root LC. There omega is nothing but 2 pi f. Omega is nothing but 2 pi. There is frequency term present. So beta is dependent on the frequency and alpha is independent on the frequency.